Hey everybody. All right, we are making our way through the types of reactions. We've got done combination, we've done decomposition, and now we're going to focus on replacement reactions. So recall that there are a nearly infinite number of possible reactions that can happen, but they all fall into a few broad categories, and that's what we're walking through now. So next is a single replacement reaction. So in this type of reaction, an element substitutes for an atom in a compound to produce a different compound and a different element. Okay, what that means in terms of reactions is, like, say you have A plus BC, and uh, we can swap a single atom. So like C would move off of B and go bond to A. So A plus BC turns into AC plus B. Okay, and this will hopefully make some more sense if we do an example. So here's an example of a single replacement reaction. The highly corrosive hydrochloric acid, which is HCl, is neutralized by the addition of magnesium metal. Hydrogen gas bubbles and the salt magnesium chloride form. Write and balance the chemical equation. All right, so our reactants are described in the first sentence. The highly corrosive hydrochloric acid, HCl, is neutralized by the addition of magnesium metal. So it's just magnesium solid, right? And it will form hydrogen gas bubbles and the salt magnesium chloride. What's the ionic formula unit for magnesium chloride? So Mg has a 2 plus charge, chloride has a -1 charge, and so it would be MgCl2. Okay? And notice, here, let me be a little more careful. Let me rewrite this. So I have HCl plus magnesium, then forms H2 plus MgCl2, right? And you can see that the chlorine, which was bonded to the hydrogen, swaps out and is now bonded to the magnesium. So it's a single replacement, and that's it. Okay. However, let's check to balance this. Magnesium is 1 to 1, and we notice that on the product side there are 2 hydrogens, 2 chlorides, and so if we put a 2 in front of HCl, it's now balanced. All right, our second example is a similar one, just because these are easy to make sense of. So here's another single replacement, and it again has to do with hydrochloric acid and a metal. Okay, this is a classic single replacement reaction, and it gets at some of the previous things that we've learned. So it gets testing you about what the parentheses mean and how to form ionic compounds and all that. So these are questions that have multiple parts that are relevant to us. So here we go. Iron metal can also neutralize hydrochloric acid. So we have HCl, and I'm just going to do it in a single color this time, can be neutralized by iron metal, and it produces hydrogen gas bubbles plus iron 3 chloride. So that would be FeCl3. So I literally think my stomach was growling and my dog started barking when my stomach growled. Um, so I think we're calmed down now. All right, so there we see again how the chlorine has simply swapped off of the H onto the iron. But in the process, it has also produced an ionic salt, iron chloride. And iron has gone from neutral metal to charged ion, which you'll soon learn is also a redox reaction. But we can just balance this for now. And let's see. So it's a little bit different, right? Because we have FeCl3. So we need at least 3 chlorines. But that gives us 3 hydrogens, which doesn't really go into 2. So if we put a 2 in front of iron 3 chloride, then we can put a 6 here, right? So we have 6 chlorine. Now we have 6 chlorine and 6 hydrogens. So I can put a 3 in front of hydrogen and 2 iron over here. So I need a 2 here. So 6, 2, 3, 2 is now balanced. Okay, one step added complexity. From single replacement reactions comes double replacement reactions, where basically we have 2 pairs and they each swap 1 part. So here, like AB plus CD forms AD plus BC, right? So they're swapping what they're paired up with. And the ionic compounds potassium iodide and lead 2 nitrate undergo a double replacement reaction. What are the products? Write and balance the chemical equation. Okay, so the products are not actually given, right? But we're told that it's a double replacement, so we can determine the products from that. But first, let's figure out the reactants. So potassium iodide would be Ki, right? K plus 1, I minus 1 forms Ki, potassium iodide. And lead 2 nitrate. So nitrate is a polyatomic ion. You can look this up if you need to. It is NO3 with a minus 1 charge. And so lead 2 is Pb, and if it has a plus 2 charge, then we would have PbNO3 parentheses 2, right? So to get the minus 2 from having 2 nitrates. So if it undergoes double replacement, then that means I and Pb will join up. So basically this cation and anion swap, right? And potassium and nitrate will swap in. So we can write it as Pb, now it's lead 2, right? So that would be PbI2, and then K and NO, plus 1 and minus 1 charge, so KNO3. Right, and we see how they've swapped, so we have a double replacement. So let's balance this, and right away, there's different ways to do this, but I noticed that I have an I2, so I need at least a 2 on this I. I also notice I have a NO3 2 here, so I need a 2 NO3, and by putting the 2 on the NO3, I also make now 2 potassium, and that takes care of this here. So it is now balanced like so. Here's another one. The base sodium hydroxide and the acid hydrochloric acid are both quite dangerous alone. When combined, they undergo a double replacement neutralization reaction to make water and the harmless salt sodium chloride. Write and balance the chemical equation. Okay, so all the information we need is given in the question. It tells us the reactants, it tells us the products, it even tells us the type of reaction. Okay, so the reactants are sodium hydroxide and hydrochloric HCl. So hydroxide is a polyatomic ion, which is OH with a minus charge. Sodium has a plus 1 charge, so NaOH would be sodium hydroxide. Hydrochloric acid is HCl. The undergo a double replacement reaction, which neutralizes them to make water and sodium chloride. All right. So notice the double replacement. So the H here and the OH here are now together to make H2O, and the sodium and the chloride are now together to make sodium chloride. And it's actually, is it balanced? Yes, it's balanced here um, without having to put any coefficients. Okay, we'll come back for part 3 and look at the last two, which would be redox reactions and combustion reactions.